G'day, I'm Neil and my handle is Wiley11. I'm just going to put my disclaimer here. Whatever I do and say on these videos is well-intentioned and well-meaning advice. I accept no liabilities whatsoever for any disclosures. If you take some advice or act on something that I'm saying on these videos, you do so entirely at your own risk. I'm doing it based on my experience. These videos are my attempt to give back to YouTube for the help and assistance that YouTube has given me. So once again, you follow along or follow advice from these videos entirely at your own risk. Okay, and if you're not happy to do that, click this off and off you go. Because this is purely my attempt to give back to YouTube, as I said, for the help and advice that I have received out of YouTube. So this is just my little attempt to give back. If you're happy to follow along at your own risk, buckle up, sit in. Let's get into it. G'day and welcome back. This is going to be the final video that I'll post in building the i3 Prusa. So it might go a bit long. I know part 6 was something like an hour and a half, and part 7, I'm not sure how much content I can put in here, but there are literally 100 hours of footage in this project, and a lot of it hit the cutting room floor because some of the footage was just terrible photography. You know, my fault. I'm not a good photographer. And others were just like really, I thought, very boring to look at, and therefore just I didn't bother putting them in. You know, like you can watch somebody do these ones. Once you've seen him start it, all you want to do is see the finished product. You don't want to see him do that for an hour and a half. You know, like some of these jobs, the tidy up of the process is often the worst part, and you can find all sorts of small issues with your build when you start going back around and doing the tidy up and just the walk around stuff to work out what's going on, and you know, the shakedowns and the shakedown tests, and just to calibrate things and make sure things are supposed to doing what they're supposed to be doing. Now that's what this final stage is all about. We're going to finish the build off in this stage. We're going to connect up to the computer. All of these things sound simple enough, but interestingly, this final shakedown, testing, calibration process has taken the better part of a month. And, you know, in between I've been interrupted with business and personal health issues and everything else that goes on in your life. Your life doesn't stop because you're building a printer. You've just got to do it when you can do it. So this is the final, as I said, in the series. It's part 7. And what we're going to do is hopefully put a montage of the final part of the build, the calibration, a few more problems that we had to overcome, and finally working 3D printer. So connected up to the laptop. Now, even connecting to the laptop wasn't easy. The driver that came on the download from China didn't actually work with my computer. So you'll recall I really didn't look at that data stick until very, very late in the build. And once I went back through the information on the data stick, I found so many things that would have saved me a lot of time. And it's a big one. You know, you've got to go through everything, every clue and everything that you're given. You got to go through it all. You can't just think, oh yeah, that's good, yep, and move on. It's not good enough, and it can cost you a lot of time, and that's what happened to me. However, once I sorted out that I could copy things onto, let me just get this, one of these things, right? And the onboard menu would take, once I had the G code, the onboard menu took care of it, and you could just run it from the I didn't have to worry about connecting to the computer to debug the problems. However, I lost the ability to turn the machine off quickly. And by the time I reached the shut-off switch, which I've jerry-rigged from a power board, the damage was done. If I'd been sitting here with my finger paused on the stop button from the computer, it's a lot faster than cutting the power. By the time you reach over there to cut the power, whatever's being destroyed on the printer, it's too late. She's done. She's all over Red Rover. But up here, if you've got connection to your computer, all you do is hit stop, and within half a second that thing stops, and it's a pretty good response time. Which is why I think the manufacturers didn't bother putting the emergency cutout. Like, even on the menu, there's nothing that says stop. You can't just push a button, like push this red button and everything just stops. It isn't there, and it should be. It needs to be. There needs to be a stop printing. Bang, hit it. It doesn't exist. Now, I'm going to put my own emergency cutout, cut the 240 volts off button, which is going to be accessible, so that we'll run all the wiring through to it, to the switch, which I want just here, that I can just reach over and go whack and whack it. If I see something's going wrong, I immediately want to stop that job. And the other thing I found was that when you push home all, it doesn't lift the head up first. What it does is it moves things, it pushes down slightly, if anything, and then moves X and Y. And that's really bad, because what can happen, or what did happen, was the thing wasn't calibrated properly, and it pushed the extruder head into the protective layer of tape that goes over the hotbed. Now, it's on springs, but it pushed it down enough that the hot end went through the protective layer, and of course it ripped the crap out of it when it moved that way, and it tore it, and it completely rendered it useless. And that was not good. It was really a really costly kind of an error, because those protective red plates, right, they cost about $5 each from eBay. But for about $20, I went and bought this roll of 3M Scotch Blue number 2093. Okay, you can see that right. Sorry, I'm backwards. Number 2093, you can see it right there. And that stuff is the stuff that the protective layer is made of, and you can buy it from, don't go to the hardware store and buy it. You might not get what you I went to a paint store and I bought it from the local guy that sells paint. When I want paint stuff, I go to the paint store. When I want bolts and screws, I go to the bolts and screws guy. When I want tools, I go to the tools guy. Only if they don't have it, then I go to the Bunnings, or as you call it, the Home Depot. And I tried it. It's like buying your meat from the butcher instead of buying it from the supermarket. If you don't support those guys, they go out of business. The supermarkets then dictate the quality and substance of what it is that you're going to get from them. Because if that guy shuts down, then you've got to accept whatever quality comes out of that supermarket, right? It's no different to your tools. If the tool guy shuts down, you've got to go to Bunnings and you've got a broken drill. Well, Bunnings aren't interested in repairing that. They'll send you to some bloke somewhere who's eking out a living repairing drills. Well, if you've got a shop that's specialising, you can take your drill in, you go, look, I don't know, this broke. And he goes, right, here's a quote, you fix your drill up. And they'll fix your drill. And when you get it back, it'll be as good as new. And you know that it's going to be reliable. When you go holding it up above your head somewhere, it's not going to grab, twist, and throw you off a ladder if you're working on ladders, which is really, really dangerous. People do it all the time. They twist their arms and all sorts of bullshit happens because they just don't care enough they want to save a few bucks, so they go to the supermarket and buy the cheap whatever. And my son did that. He bought me a set of tools from the supermarket, and they're quite good tools. But if I need to get them repaired, I can't. There's just no one that services those tools. So I'll use them until they wear out, and then I'll rate them for parts, and whatever's left will get chucked. The batteries are pretty bloody good though, and the tools themselves are pretty good. They haven't let me down to this point, but it's only a matter of time before they will, because they're not the quality of the things that you buy from the specialist tool guy. Righto, so enough ranting and raving. Let's get on to this build. This is our final part of the build. I've been in it for 10 minutes. Now, please support my company, nightglowmanufacturing.com. And, you know, I can continue to shoot videos and feed myself. So basically, you know, if you don't support me in terms of that, support me, because nightglowmanufacturing.com is about saving the planet. Righto, let's get on with it. Hey everyone, welcome back. I don't know what I can do to fix this glary light situation. Yeah, maybe, don't know. 3D printer build. Yeah. Build is that far from being complete, and it looks like it might as well be this far. I've just confused the living bejesus out of myself with where I got up to and what I'm trying to achieve. I've changed the manufacturer's design. Let's put that out there. I've changed the manufacturer's design for the wiring. I decided to incorporate a fuse box to protect the hotbed and the extruder with 30 amp fuses in it. And because it's only a 20 amp power supply, I think a 30 amp fuse should be fine, because if you get feedback, you'll get 40 amps and it should blow the fuse. Yeah, because it's 20 amps of output and there's a hotbed and an extruder, they should be sharing about 10 amps each, unless they've done something clever with the amps in the circuitry, which I'm not going to even bother looking into. But what I am going to do is put an ammeter. I've got this clippy thing which you can just see hanging up over there. So I put that over the cord, and we'll look at how many amps the system draws and just make sure that 30 amps is fine. So we're going to do that. It might be too high. We might have to drop it down to 20 amps. Because if each one of those is 10 amps, then you're never going to hit 30 amps. You're going to hit a maximum of 20. Unless there's some exponential build-up of power, in which case you'll hit 30 amps without a problem. But I can't see that happening in a heater circuit. It's essentially a heater coil, you know, which draws, I don't know, whatever amps are available and turns it into heat. So if it exceeds that, the heater coil explodes, and you don't want that. So you just got to work out what's the limit of the extruder. And I guess the data sheet for the extruder would be a good place to start. But I don't know what kind of extruder it is, so I might just look at, you know, what's the average consumption of an extruder and what's the average maximum they're supposed to reach. And if it goes above that, then blow the fuse. That might be a better place to go. And it's the same for the hotbed. I've got the make and model of the hotbed. I should be able to get a data sheet and work out what the maximum amps are, and then put a fuse on that line as well. So that's perhaps a better way to go. But I'll actually physically look at what they're drawing before I go down those roads. And, well, why don't I just go down those roads? No, why don't we go to data sheets? We should be able to go to data sheets. Righto, so I've used 30 amps, but that's a guess. You know, that's just off the top of my head. It's probably way in excess of what's needed. Right, so what's next? I haven't put a fuse on the main 20 amp line, 12 volts in. Now the reason I didn't do that is that there's a fuse in the power supply. I saw it there when I tweaked up the lid.
I got a cup of tea today because I shouted myself a coffee shop cup of coffee cost me $5. So I'm having a cup of tea. Now, paying $5 for coffee is exorbitant, but we had a meeting and it was a good meeting and I felt like celebrating, so I shouted myself a $5 coffee. And having good meetings is good. I wanted this working today. We've missed the deadline for having it working. It transpires that it's not critical to my thinking because I always set deadlines kind of a week ahead of when I actually need a deadline. So I've got a little bit of wiggle room to get that working the way I want it. It does work. You know, the motors work and everything kind of works the way it needs to. It's just that nothing works the way it's intended to work in terms of being used with software. And that's the bit that I've still got to sort out. So I can plug it all together and get things working. That's not a concern. But it is a concern that there are too many things that aren't installed that need to be there, such as a cutout switch, which I'll actually wire into circuit and then get an electrician to sign off and tag it before I start using it. So it needs to get tagged by a licensed electrician, so that needs to occur this week, and everything else just needs to be tested. Now that said, I have a 12 volt power supply over here, so given that that's a 12 volt output at 20 amps, that's way under power because the maximum that can go to is I think about 10 amps, that power supply. But I do have a 12 volt car battery which will output 20 amps. So I can just wire it directly to the battery with a switch and then it'll supply power until I get the power supply sorted. So there are ways around the problem is what I'm telling you. I don't want to use a way around it. I want to do it the way it's intended to be used in a safe manner. So let's get to that position. Let's get to that position where everything is safe and it's easy to use. And I prefer to reach that, and I've set the deadline back to this Friday because I've still got to get an electrician to sign that off. Right, it's 12 volts, so I'm not concerned about the 12 volts. I am concerned about the 240 volt power supply that I'm adding a switch to, a cutout switch. By installing the cutout switch, the unit will be safer, but it also voids anything the manufacturer has done because they never put it in there. So it's not safe for Australian manufacturing standards because it has no safety switch. And I need that in there. So I'm going to get that happening. Okay, what's next? I think I'm going to leave the build at this point. I'm just not going to be working any further until I've organised the electrician and everything is safe. I think that's a good point to leave the build, so we're going to end the electrical wiring at this point, and then we're going to do an epilogue episode where we will review all of the gotchas, everything that got me in the build. And if all you want to do is know what to look for when you're assembling your own kit, then that'll be just a piecing together of every gotcha I had during the build, and perhaps you'll skip straight to that in the series and just look at the gotchas. So I'm going to end this video. I want you to make good decisions and do good things. I want you to keep on swinging at it, whatever the project is. Don't give up on it. If it's a worthwhile project, stay in there. If it's anything like me, you're copping all sorts of flack and opposition to what you're trying to achieve. I'm getting that. You're not Robinson Crusoe. Keep swinging. Good decisions, good things. Thank you for tuning in. Subscribe, like, comment. You know, share this around. Make sure people understand that we've got a worthwhile goal. And I'll catch you guys at the next one. And don't forget to support nightglowmanufacturing.com. Thank you. Yeah, I'm just having issues with the wiring. I found where this fan is meant to go. It's meant to go at the front of the extruder caddy, but what I can't see up there are any mounting points for it. So while it says put them in there, it doesn't appear to have given us any way of actually mounting them on there. I do note though that there is a self-tapping screw in there, in the bag. So maybe you're meant to force that screw in to mount the fan. I really don't like the thought of any of that, so I'm going to think about that before I do anything with it. There's been a few parts to this build, you know, now that we're in the home stretch with it, that have really got me, that have really caught me out. Things like mounting the 12 volt wires into the control board. Well, yeah, okay, you can do it fairly easily if the board's out, but once the board's in situ, unscrewing screws and pushing wires in and then screwing them back in is fraught with danger. So you really need to mount all of your 12 volt wires first before you mount your board. Now what I did was I put the board on and started running wires, and now I've got to take the board off again and mount those 12 volt things and put my 30 amp fuse system in the middle. So that's all got to get done. So that's really where the build's up to. It's pretty much in its final stage, pretty much. There's a bunch of wires running in all directions at the moment at the back, so everything needs to be tight. And also, I've chosen to run my wires a little bit differently to the way that's shown in the pictures. And the reason for that is that I don't like, I just don't like the way things are being done at the moment with this other build. Unless there's some way of holding those wires proud of all those drive shafts, which there probably is, and I'll have a think about it. So that when the wires come down, they're not going anywhere near the drive shaft. So yeah, then you could run it right up and over the top. I won't have any problem with that. There's enough wire. There's more than enough wire, but it means everything's got to get unplugged and rerouted again. So I'm going to have a think about it. You know, we're not going bull at a gate. We're just going to have a think about things. The other thing you've got to be conscious of is that the PLA comes in from the top as well. So you've got to find a way of running that material, that it's coming up and it won't be impeded by the operation. You know, it's got a free flow of material into the extruder. I'm really struggling to finish. We're at Friday afternoon, which was supposed to be the final thing. I'm kind of there. I haven't got it working, but all I've got left to do is to figure out the wiring, and I'm over it. I've had 3 days of fiddling and fighting, and I mean fighting. This final stretch, this machine's fought me every step of the way, and I've had to work some things out. I had to completely reassemble the control box at the top. That cost me, you know, almost a full day of re-engineering the way that all sat together and did things. Wonderfully, they've provided enough hardware that you can change your mind and do things a bit differently. But it's not apparent what hardware to use and where. That's the first thing. And the second thing is, you know, when you come to things like this fan here, and they give you the fan and then they expect you to, you know, there's a self-tapping screw there. And obviously you're meant to put the fan together with the self-tapping screw. But what the hell is it supposed to mount into, you know? Like, I don't like the idea of self-tapping screws. I prefer to see some kind of a receptacle or bracket for that fan. and that might be something that we'll 3D print and put on there, and then we'll mount it to the bracket. Well, the other thing is are we missing a bracket? Is there another bracket that I've lost or something? I can't see a bracket around the fan, but putting the fan in there also, it covers over the adjusting springs and the adjusting screws for the feeder. So there's no real reason to put it in that position other than to keep all of that equipment at temperature suitable for operation, given that it's sitting above the extruder. I'm a little bit perplexed, and I just need things to work correctly. So here's hoping things will work a little bit better, and I've had a chance to think about it. I might come back to this tomorrow, I think. Welcome back. I've been staring at the build for the better part of 3/4 of an hour, just getting right in my head how I want to route all of these wires. We've got two little problems. They're not massive. You'll see that I managed to break one of the tech screws that they supplied off in the build. It's living there for the rest of its life. I didn't bother trying to get it out. I just drilled a hole beside and put the clip on, the P-clip for the cable next to it where I wanted it. But that's fine, it's worked out all right. The biggest problem I've got is deciding where to run the Y-axis wires such that they won't bind up on any of the moving parts. And when you look at the way they've done theirs, they actually run it up in the air from the back. But the problem I have with what they've done is they've run the whole thing in a single harness. So they've got the signal wire inside the same harness with the power wire. Now, because they're traveling in the same direction, you wouldn't expect the signal wire to have an issue in terms of signal, but I do have an issue in terms of heat. Now, the outer tube of the power wire is braided, and it's a heat resistant material, like it's rated for heat. But the signal wire isn't. It's not rated for any kind of heat whatsoever. So if anything comes through that braid, it hits the plastic of the signal wire, and we got a problem because it's going to melt and wires can touch, and we've got a signal where we shouldn't have a signal. So yeah, I'm thinking that through. Now I know that somewhere in Zoomi's kit bag I've got some fiberglass sheath of varying sizes, and if I've got some sheath there, then what I might do is might use my fiberglass braid sheath around the power wires, and then put the whole thing in the harness up to the control box. So I'm thinking that way, that I can use what I built for a different build, but then I've got to go and replace it. Of course, I've got to buy more in, and I've got to assume that I've got the right size too. I don't know if it's the right size or not. I might have to wait, I might have to order it in and wait for it to come. But I can't afford to keep putting this build off. I've got to get it up and running and working. I need to use it. So I'm at catch-22. I can leave the power wires out of the harness altogether and come back to it at some other point. That's an option. I run the risk of the wires getting fouled in the job or in some machinery if they're not in a harness. So I'm not real happy about that solution. I can wrap the power wires in just tidy them up with cable ties so that they can't foul. But I don't like that solution any better than I liked any other one. I'm really at a loss as to what I should be doing next. And I've been staring at the job for nearly 3/4 of an hour, just satisfying myself that I've done the right thing. And I'm just looking at the harnesses and making sure that I can't foresee any problems with anything fouling up on any moving bits of machinery. And when we get finally in place, in position, we want to make sure that the wires are not going to be sitting against anything electronic, that can heat up and melt them. So, for example, I'm passing some wires below the control board. I want to make sure that I tape them off to the frame, that tape is going to keep them proud of that control board, that they're not going to sit against it. And there's some power wires running in there as well. So once again, I've got this issue. And I'm also staring at the 30 amp fuses that I've decided to incorporate in the process. And I'm actually wondering whether I need to. I'm half convinced I don't need to. But, the engineer in me says, what, you can't live with what you can't live with. And without a fuse in that high power line, it's a 20 amp line, and it can get hot. Now, if you get feedback, you've got 40 amps. And if you've got 40 amps in a 20 amp line, something's going to give. The amps don't cancel, the amps double, right? So it's funny like that, but even though you've got the voltage cancelling, the amps don't cancel. They don't. Feedback is terrible stuff. It screws with your head, it screws with your equipment, and it only requires any kind of a jam or any kind of a short, and you've got feedback and you've got a problem. I don't know is the answer. My gut's telling me you need the 30 amp fuses, and my head's telling me you need the 30 amp fuses, but pressure is telling me they didn't incorporate that into the build, so why are you? And the answer is because I want to be safe. So I'm going to do it. I've convinced myself I'm going to do it. I'm just going to have to find a good spot to intercept things and put it in the build, which means I've got to make myself a bracket and a mounting point for the fuses. Now I can do that. I've kept the bits and pieces from when I pulled all the old videotapes, all the little sprockets and screws and springs and things that were in the video cassettes. When I ripped them up and shredded them and whatever, I kept all the innards, and there's little springs and there's bits of beautifully anodized steel that you could use for this job. And some of them have got, like if they were a better quality video, they've got like a chromed bit of steel there, and I could make a bracket by bending it up to go into the fuse holder and then bending it to 90 degrees as a standoff from the frame, and then just mounting it. And if I could get that mounted, I think I'd feel a lot better about life, the universe, and everything. So my thinking is that I need to do this, and sooner rather than later. To do it, you've got to shrink the corner, and I don't have a shrinker, but I do have something that's just as good. Got a pair of multi-grips which I'm going to use, and maybe someone will find that interesting, I don't know. But essentially what I'm going to do is compress the metal as I bend it. What you've got to do is you've got to push the metal together so that it actually compresses and pulls the ends in, and that's what a shrinker does. It grabs and pushes together so that your bend comes this way, and your metal actually gets thicker, and then you sort of squash it flat and push it in again and squash it flat. So you can certainly do it without the shrinker, without the machine, but you just mimic the process with what you got. And I haven't got a hell of a lot here, unfortunately. I've got plenty of tools, but I haven't got anywhere to set up to use that kind of equipment. Okay, well, I've been rabbiting on for nearly 8 minutes, but these are the issues at the end of the build. I wanted to get to the point for Monday where I'm using this machine, and where it's Saturday, and we're a day over where I wanted to be on Friday night, which was finished Friday night. We only had the wiring, to wire it in, and this is where we're hitting these issues of the wrong wire too. The X-axis switch stop has a much longer wire, and I used it in the wrong place, so I had to pull the wires off and move that wire, and then pull the other wires off and move that. Luckily I realised it before I put everything in harnesses, because I was actually test running wires around the place to make sure I was going to reach where I needed to reach, and that's when I realised I had that problem. So you've got to pay close attention to your job. Like when you're feeling your way through it, you've got to think it through and don't be in a rush. And this is why I've sat there for 3/4 of an hour and looked at the job. I can see also that my 240 volt lead needs a P-clip on it, and there's just nowhere to mount it, literally nowhere. And what I wanted to do was come off of one of the bolts, but it's structural and on the frame, and the P-clip's plastic, and you don't want a structural bolt going through a bit of plastic, so you're going to have a metal P-clip for it. And the other thing you don't want is a metal P-clip around a 240 volt cable, so what you've got to do is make a metal standoff and then the plastic P-clip. I'll be quite happy for that structural bolt to go through a metal standoff, and then the P-clip on the other end of the metal to hold the cable. So I'm going to make that as well while I'm doing a bit of metal work. So they're the two things I need to get made. I need to do those today. I can use Sunday to tidy up the wiring. Everything's wired into the board. I've got everything plugged in, apart from the high power, the 20 amp 12 volt stuff. And I haven't wired that in specifically because I want to run that fuse box, and I want to sheath those wires in the fiberglass. So the two jobs are make the metal bits for your standoff bracket and your fuse holder. So you want to make those two metal pieces, and make find the braid, for the high power, the 20 amp stuff. So that's it. That's the jobs. The reason I'm feeling a bit shitty is I haven't had my beautiful treat to myself cup of coffee yet. It's a 50-cent cup of coffee this week. So I'm going to have a crack at that. And then what? Well, after coffee, I think I'll have a go at the metalwork first and get those brackets made so that I can mount them on the job. And once they're all made and mounted on the job, run the wiring through to where it needs to be, and then see where we are with a little test. So we should be ready to test on Sunday afternoon. And I'm still on top of where I need to be for Monday. I've got a meeting Monday morning, and then Monday afternoon I should be using this thing to produce prototypes, because I've got everything else put together. I've got even to the point of making this thing, the bracket to hold your PLA spool. It's all made up, ready to go. Everything's made, apart from the metal bits that I need to get done today, and I'm literally going to be using vice clamps, the metal lockjaw pliers or vice grips, and that's what I've got here. I haven't got a bench vise. I haven't got any of that stuff that would be really useful for making these brackets. A mate of mine's got it, but I'm not going to go and put pressure on him. I'm just going to sit here and fiddle with what I need to fiddle with and get things finished. Alright, so let's get into it. Stop mucking around. First job is coffee, find the bits, get into it. Righto. Right, so the way I've solved this is that this plug was actually bent down, and I actually used a bit of brute force and bent it back up. So now it clears. So that's an issue dealt with. I'm going to continue with the build. I'm going to put this plate back on the way it was, so you don't have to reorient it. All you need to do is if your plug is down, just bend it up, which is what I've done. And it must have been bent in transit, I think, because I can't imagine why it would be bent. But anyway, there we are. Is open the example file, examples, basics, and there's a letter block. So there it is, letterblock.scad. Now this code introduces you to this module. And you see here he's got a lot of magic numbers in his code. So I wouldn't recommend that you follow this kind of programming example, because all of these magic numbers here should be declared as variables somewhere up here so that you can change them at will. All of this font, all of this can become variables, size, X and Y. So this is, all of this stuff should be variables. He's got magic numbers. He's used a variable here, but he's given it a magic number there. Right, so let's get into it. What you've got to do with this first is you've got to render your object. So to draw the preview, you hit this button here, preview, which is F5. You can render it out, which is F6. This is the Windows version, guys, so this is what I'm using. So I'm going to do a render. Rendering is all finished, as you can see, 48 facets, whatever. And now what we're going to do is we're going to develop the STL, which is F7. And I'm going to put this somewhere where I can find it. For the moment, I'm just going to chuck it on the desktop. Okay, so that's it. We're done. Export finished. I've got letterblock.stl, and I'll just minimize this. You should see it sitting somewhere. Here it is. There it is on my desktop. Right, so we're finished with OpenSCAD. I'm just going to minimize that, and down here I've got Repetia. Now Repetia came to me on a 3D stick. Sorry, a 3D stick. I got it on a data stick, but I also got given a link somewhere, and I'll find that and give it to you so that you can download Repetia and all of the stuff. It came with the Tronxy i3. Here's my stick that I got. I got it with, when I bought the printer kit, it came on a USB stick, and that's what I decided to use. It was free. I double checked the licensing online. It's free. So I've installed it in Windows, and I'm working in Windows 10. So here's my Repetia. I've got 2 minutes to do this real quick, so I want to load my file in. Here you would connect to your printer. I'm not connected to my printer yet, so I'll do that when I've got time. I don't want to be there. I want to be on my desktop, and there should be a letter block. Here it is. I'm going to open that, and here's my block. Now if I zoom out on the view window, you can see that this is my hotbed, and my M is centered in the center of my hotbed. What I can do here is I can copy, and I can make copies of it. So I can, I don't know, let's do a couple. Let's do 4 of them. Right, so I've created 4 copies of the letter. Let's copy another one. So now I've got 6 letters. Interestingly, I could have chosen different letters. I could have done these as little Lego blocks. I'm going to go into Slicer, and you can see here the CureEngine Slicer is already built into the Repetia desktop. So we're going to use it. And we're going to slice this thing up. So this is slicing up the job. And this is all important stuff. So what it's done is it's created G-code. We can see that in a minute. But what I want to look at here is this thing here. It says I need 14 centimetres of 14,000 millimetres, 14, hang on, 140. Let's look at this again. It says I need 1.4 metres. No, it says I need 14 metres. 1,000 millimetres in a metre, right? So it says I need 14 metres of filament to do this job. I don't know why it would need that much. I mean, that's a hell of a lot of filament. 14 metres is a hell of a lot. So let's go back to Slicer. Let's get into the configuration for Slicer. Alright, here we go. And what we're going to do here is we're going to see the infill's at 60%. Let's bump that out to 70. And let's put this at 120 millimeters per second. Now before I want to save this as, oh shit, can't control Z. What was it? This was 100 and this was 60. I killed it. Right, I want to save that back into default. Let's save as testing. Right, so now we're in testing, and what I want to do here is I want to bump that out to 70, and I want to push this up to 120. Skin infill 30. I'm happy with it, a bit rough. I'm going to push that out to 40 and 60. Right, let's leave all that alone and save that and close it. Now let's go to Slicer and reslice it. And we saved about 220 centimetres. That's a lot of filament. I don't understand why it's so much, but it's a lot. And you can see the job. There it is. Alright, I'm going to go back a bit further. I'm going to go back to object placement. I'm going to delete 2 of those. Let's delete 3 of them. You know what? Let's delete all of those. Let's just do 2 of them. 4 meters of filament. These must be bloody big blocks. I don't know how big they are. Righto. We're going to look at the G code real quick, and you can see here that my STL file has been turned into what they call G code, which is coordinates. So it tells you how hot they want the extruder. So this is where the head will move to. X and Y coordinate, and what the extruder temperature is expected to be when you get there. Now you can see that's created 27,000 lines of G code to run that job. That's not bad. You can actually jump in here and change things if you want to. I don't bother, but you can. Right, so I just want to clarify the amount of filament needed and how it was calculated. So what they've done is that they know that the filament head is 0.2 of a millimetre. And so it's 0.2 of a millimetre, or 1/5 of 1 millimetre. And everything else is in millimetres. So all they've done is work out the cubic millimetres there are in the job. And if you think about it, it's 30 by 30 by 15. So that comes to 13,500 millimetres, or 13.5 metres. That's right. 13,500 millimetres. A metre is 1,000 millimetres. So it's an astonishing amount of PLA, 13.5 metres. But then you've got to divide that by 5 because you're using 1/5 of it. So that comes down to 2.7 metres. So each of those blocks is 2.7 metres of filament. That's a lot of filament, 2.7 metres of it. It's like, just to make something that's 30 millimetres square. That's a lot of filament. Anyway, let's see if it does. I'm going to measure out 2.7 metres of filament and see just how much of it's left over at the end of the print job, and see how accurate that process is for estimating how much filament you need. It's an interesting process, that's all I'm saying. Right, so we can close that editor. Right, so that's what I'm going to end up with. So it's going to look. Right, so that's a rendering based on the fact that I changed the skins and the infills and etc, etc. So, you know, it's going to work. You're going to get something. It's going to print out somewhere in the centre of the bed. It's not going to be off the edges. So one would hope that we'll be able to calibrate the printer and hit the go button. Shows you the speeds at which the thing's going to run round. Now, interesting, it's going to take about 54 minutes and 12 seconds to complete this job. And you can see it's going to build these structures here, which are going to have to be cleaned out of the job when you finish. You can build this up layer by layer. And you can see it come to life. Layer by layer. Cool, eh? It's not a bad bit of kit for free. Here's your temperature curve. So this is monitoring, this is doing live monitoring of your of your printer. So when you do this connect, it wants you to tell it all sorts of things, so that you can, oh look, you got multiple language printer settings. We can go there. Printer. Cool. Auto detect. I'm quite happy to leave all of this alone. I think this is a pretty good bit of kit for free. It's a very good bit of kit, and we'll be able to run it. And it was effortless to install this. So here's your printer settings there. Here's easy mode. Right, okay, so that's just enabling or disabling those. There's an emergency stop here, so you can cut power to the printer here. So you can go, hey, stop. So there is an emergency here, which is good. It's good to have. Tells you down here, connection error. That's not bad. I'm happy with that. That's a good bit of kit for free. That's an excellent bit of kit. Alright, we're done. We're going to move on. So what's going on? Trying to do a print job. The problem is, this filament is not going through the system. Now I fudged the operation to make this happen. You can see that the Z-axis has some issues, because you can see that it's actually dragging its ass around the plate. The X-axis switch is in the wrong position. See, that's not. Yeah, I've got to kill this job. Hang on. I don't know how to kill the job. Configuration. Oh, there's one way to kill it. There we go. Job's killed. I'm going to turn it back on because I don't want it to print, but I do want those fans on. Okay, so we're up on the menu. I'm going to go here, and I'm going to go position. And I want to go home all. Look where it thinks home is. And that's because that X position switch there, right there, is in the wrong spot. That limiting switch needs to come over. Now there's a couple of good things about what my setup is. First of all, I can really quickly check for level on everything. It's easy to do. You can see it's gone out of level slightly when it started operating. Just a bit. That one there is perfect. That one there, not so perfect anymore. So I've got a couple of issues with the way it operates. I worked out that if you chuck your file on your G-code file on an SD card and you chuck it in there, in the slot, you can actually then use this menu up here to actually get it printing. And you don't have to worry about anything else. Now you can see that everything's cooling down quite nicely. You've got to leave your fans on, you know, like you can't just shut everything off and then turn everything off. You've got to have your fans on so you don't burn up your extruders and you don't burn up your hotbed. You don't kill them. Now what I didn't do then was I didn't look at the draw on the current, so that was a bit of an issue, but we'll do that in a minute. But I want to sort out how to get this filament loaded in the Tronxy. Got to be a way to load the filament in without having to take the fan off every time you do it. Now I think it has something to do with this screw on the top. So I can't see it very well, but see that screw on the top there? The filament goes into that hole there. But I think you've got to let that screw there off, pull that up and then load your filament and then push that back in. I'm about to find out anyway. Righto. So what I've done, folks, is I took that fan off so that I can see the mechanism. With the filament coming down, which you can just see comes down into there. So what I'm going to do is I'll see if I can get this thing to work by pushing it down with my fingers into that. Now I've adjusted this screw here down a bit tighter, because the only way it could go, it was as loose as buggery. So what I did was I adjusted it down tighter. But see, it has to pick this filament up, and it hasn't done that yet. So that's what we're endeavouring to make happen, is to get that filament to pick up. And what we'll do is we'll put some tests on our ammeter while it's working. We'll see what our current draw is on that. Rightio. That stepper motor is not picking this filament up. Well, it is now. We're going to adjust that on the fly, see if we can get it to There's something really wrong with this. Okay, I'm going to cancel the job and I'm going to try it with the purple filament. Okay, so what I've done, just quickly, so I've taken a set of verniers, upside down and back to front for you guys, I know, but I'll put them on this one. And you can see it's about a 1.5 mil. I'll put them on this one. It's 1.54 mil. So the filament they've provided is the same as the filament I've got that I bought, but I'm going to try it with their filament. Let's go again. Got to be some reason that is not doing the job. Bring you guys over this way a bit. Should be able to see what's going on there. I'll just use this filament, put it up over the top again, down through there. Righto, so that's that. Heading up to print file again. I'm going to use their filament. Let's see if we can get this to go through. Now I haven't adjusted this from when they sent it to me, right? So the manufacturer preset all this. I've just got their cooling fan hanging over here, hanging out. It's not actually doing anything, so it's fine. Probably doesn't know it's got a second cooling fan, I don't know. It's definitely not using it. Things are heating up. But this extruder is not working the way it's supposed to. See it, purple stuff. Push it down. It hits the point. There's an adjusting screw here to adjust tension. And what I've done is I've backed this tension right off. But I can't push that down at all. So if I tension it right up, I wonder, is that what you're supposed to do? The more you tension it, it's as tight as it goes. Let's see whether that works. I've no idea what that's doing to this guide over here on the right. I think it's pushing against that guide. That's as tight as that goes. Doesn't go any tighter. We'll see if it pulls that through. The two extruders, the hotbed's at 50 degrees, which it is, and the extruder's just heating up. Here we go. Let's see what happens. It's on its tightest setting. Yeah, you can see what's going on. That stepper mode is working, but as soon as I try to feed through that, nothing happens. This has got flies on it right here. We're gonna stop the job again. All I'm doing there is I'm making holes in the bed. Just turning everything back on to make sure it cools down properly. Starting to dig holes in the bed. I've got to get some of this tape. I'm going to have to pull this extruder apart. I don't know what the story is with this, but it's not right. Whatever's going on with it, I don't understand. But it's definitely not right. So we're going to pull that apart and we're going to have a look. I'll wait till everything cools down, we'll come back to this.
Okay, so what I wanted to do was have a full finish up, but we've got 2 hours of footage, so I'm going to have to split it in half. So we're going to finish it here. I want you to like and subscribe to the channel. You know, like the video, subscribe to the channel. Like the channel if you want to like the channel, that's good. Make good decisions, do good things, keep swinging at it, and I'll see you for part number 8.